In this video, we're going to learn how to solve these JAMB Physics repeated questions under propagation or production of wave. We're going to practice with 8 repeated questions for this subtopic under wave. So let's get started. The first question I have here says, the equation of transverse wave traveling along a string is given by this, where y and x are in cm and t is in seconds. Find the maximum displacement of the particles from the equilibrium position. Now guys, for this particular question, basically you don't need to solve anything. Alright, so all you need is to know how to interpret wave equation. So in this particular question, this 0.3 we have here is our maximum displacement. So the correct option here is option C, which is 0.3. It's as simple as this. You don't need to waste time for this kind of question. So let's go to the next repeated question. Okay, so the next repeated question will be this one. A traveling wave moving from left to right has an amplitude of 0.15 meter, a frequency of 550 Hz, and a wavelength of 0.01 meter. The equation describing the wave is, now guys, because of time, this is a repeated question. Just take note of the correct equation. The correct equation here is option B, which is y equals 0.15 sine 200 pi in bracket x minus 5.5 t, representing the time of the wave. Alright, so I've actually solved this equation before, so that's why I'm able to decode that the correct equation is this option B. Alright, so just take note of the precise answer for this particular question. Alright, so the correct option is option B. So because of time, let's go to the next repeated question. The next one is this question. It says the above figure shows the motion of a progressive wave along a string. The particle motion of the medium is in the direction. So for this particular question, the correct option will be option A. So the particle motion of the medium is in the direction parallel to OY. Alright, so along this axis, let me show you. This is the OY. Alright, so these are OY. So that will be the particle motion of the medium. Alright, so let's write this now. So next repeated question, which is this one. It says a wave is represented by the equation. This is another wave equation where x and y are in cm and t is in seconds. The velocity of the wave is, now for this particular question, if you know how to interpret wave equation, you will know that this will be the velocity 60. Alright, will be this 60 we have here will be the velocity. So the correct option is option C. Alright, 60 cm per second. So that will be the answer to this question. Alright, so this is a repeated question, guys, so just take note of these repeated questions. I'm showing you the precise answer in case they get repeated again for you. Alright, so let's go to the next repeated question, which is this one. Alright, so before we attend this question, if you are new to our channel, ensure that you are subscribed to this channel for more videos. Really appreciate this, guys. So having known that, let's attend this question. It says the unit circle per second is the same as, I think we have attempted a similar question like this. So the correct option here is option D, which is Hz. Alright, so Hz is a unit of frequency. Alright, so that's the correct option here, option D. The next repeated question will be this question. It says a wave is traveling in a medium with a frequency of 500 Hz and a speed of 350 meters per second. What is the wavelength of the wave in the medium? So for this particular question, you know the conventional formula for wave is V equals frequency times wavelength. This image for my wavelength. Alright, so in this question you're looking for the wavelength actually. So in the parameters we have the velocity, which is speed here to be 350, equals, now the frequency is what, 500 Hz. So times, we're looking for the wavelength, which is unknown. Let's call it x. Okay, times x. So basically, to make x the formula, you divide both sides by 500. So your x will be, you punch this on the calculator. Let's see what it's going to give us. So we have 350 divided by 500. So we have the output to be 0.7 meter. So the correct option in this question is option C. That would be the wavelength for the expression. Alright, so let's wipe this now and solve the next repeated question. Okay, so the next repeated question will be this question. It says a vibrator causes water ripples to travel across the surface of a tank. The wave travels 50 cm in 2 seconds, and the distance between successive crests is 5 cm. Calculate the frequency of the vibrator. Now, this distance between the successive crests is basically the wavelength. Alright, so to solve this kind of problem, this is the formula you apply. We are looking for what? The wavelength and the distance. Calculate the frequency. So to get the frequency, we are going to use this formula, the speed over wavelength. That's the formula we can use to solve the problem. So I will know that on the question we are given the wave traveled 50 cm. I know that speed is distance over time, right? So the distance is 50 cm, that's 50 over the time, there is 2. So this will give us 25 cm per second. So when you plug the value here, you're going to have 25 over the wavelength, which is the distance between successive crests, is 5. So when you divide through, you are going to have the output will be 5 hence. And that will be the answer to this question. The correct option is option D. Alright, so it's as simple as this. Let's wipe this now and solve the next question. The last one before we call it a class. Let's wipe this. Alright guys, so the last repeated question will be this question. It says one end of a long wire is fixed while a vibrator is attached to the other end. When the vibration is energized, the type of waves generated in the wire are option A, progressive and transverse, no. Option B, progressive and longitudinal, no. Option C, stationary and transverse, no. Option D, stationary and longitudinal, correct. So the correct option in this question is what? Option D. The type of waves generated in the wire are stationary and longitudinal waves. Alright, so that's it for this video. Hope you learned something interesting from the video. Let's call it a video, guys. If you are new to our channel once more, ensure that you are subscribed to this channel and hitting the subscribe button for more of our videos. Also like, share and comment on this video. Tell me how you feel from what I learned from this video. If you seem to have any specific questions to ask, I don't know what I talked about in this video, feel free to leave your question at the comment section below and I'll be sure to give you a response. Also ensure that you're part of our channel membership by clicking on the join button, where you will be getting special information that will simplify your academic work. Join us now and you'll be glad you did. Click on the screen above and I'll see you in the next video. Thanks for watching.